Good morning, everyone, and welcome to today's Food for Thought seminar. My name is Niall Grieve, and I am part of the Food for Thought team. Before I introduce you to today's speakers, I would like to remind you some housekeeping information. As it's a Microsoft webinar event, you can't unmute yourself or come on camera, and the chat function is also disabled. We do, however, welcome any questions or comments you may have, and you can post these in the Q&A box, which should appear at the top of your screen. Please do note that any questions will be picked up at the end of the presentations, but please feel free to ask any questions using the Q&A box as we go along, and we can cover all of these at the end. Today's seminar will be recorded and will be uploaded to the IFTSA YouTube channel shortly and circulated in due course. We're always looking for recommendations of new speakers to invite, so if you have any suggestions, then please do let us know at our email address, which is foodforthought@food.gov.uk. For today's seminar, I would like to provide a very warm welcome to our speakers today, Jenna Fryer and Ivannova Lituma. Jenna is the 2023 winner of the Campden BRI IFTSA Graduate Research competition. She is a PhD candidate in food science and technology at Oregon State University. She received her bachelor's degree in food science from Ohio State, where she developed a passion for sensory science and human perception. Her interests lie in how people perceive the world around them and the whys of people's food preferences. Her current research topic currently focuses on the impact of wildfire smoke on wine and their sensory properties. We also have Ivannova, who is the 2024 winner of the Campden BRI IFTSA Graduate Research competition. She is currently a PhD candidate at Louisiana State University, with her current field of research focused on the effect of UVC light against Listeria, monocytogenes, on hydroponically grown lettuce and its effect on quality. She received her bachelor's degree in food science and technology from Zamorano University in Honduras and has a passion for developing innovative, practical, and sustainable ways to increase the safety of our food chain. With that, I'll hand you over to today's wonderful speakers to discuss their recent research topics. And from all of us at the Food for Thought team, we hope you enjoy the presentations today. And I'll pass you over now to Jenna Fryer.
Hi, everyone, and thank you to the Food for Thought team for including me in today's seminar. So before I get started talking about the work that I've done in understanding the sensory impacts of wildfires on wine, I'm going to start off with just playing the video that I submitted to the Campden BRI competition and won in 2023. When we think of smoke and food, there are several things that come to mind. Smoked meats and cheeses are just a few examples of how smoke is used for positive flavor experiences. This is because smoke contains over 500 volatile compounds that impart distinct flavors. In these circumstances, smoke is added intentionally, but when added unintentionally, this can have disastrous results. Hello, I am Jenna Fryer, and I'm a PhD student at Oregon State University, working in Dr. Elizabeth Tomasino's Enology Lab. My work focuses on the impact of wildfires on wines, specifically the flavor alterations when there's this unintentional introduction of smoke. When a wildfire occurs, smoke from these fires can travel to vineyards. The grapes are then able to absorb the volatile phenols contained within the smoke. These compounds then make their way through the winemaking process and are found in the resulting wine. Additionally, it has been discovered that there are also volatile thiophenols that are uniquely found in smoke-affected wines. Both of these compounds, in combination, create the smoke flavor experience. Now, what is this smoke flavor experience? While smoky notes can be found in some wines, specifically wines that are aged in oak, smoke-affected wines have some additional attributes. These wines are described as smoky, along with having burnt, dirty, and chemical aromas and flavors. All not overly pleasant and are considered deprecators to wine quality. There is also masking of the more pleasant and typical wine attributes, like fruity and floral notes. Finally, there is this lingering ashy finish, which is kind of like licking an ashtray. Not the most enjoyable experience and not what most expect in a bottle of wine. These sensorial effects are exactly what I'm trying to understand. Wildfires have begun to spring up in wine-producing regions around the world, and with the projected 70% increase in fire danger days by 2050, these fires are not going away, and the effect of them on the industry has been overwhelming. I am trying to better understand what flavors are perceived in these wines and correlate them with the chemical composition to determine what compounds are causing these flavors. Finally, I am looking at consumers' reactions to these wines, trying to understand what their opinions, attitudes, and emotions are to them. Because some people may like it, or may not be able to perceive it at all. Our lab works on both the sensory and flavor chemistry, collaborate to better understand this problem, and I'm excited to be a part of solving this puzzle. Now, all this being said, if you see a wildfire-affected wine, don't fear it. Give it a taste and see what you think. This is a great way to see how our environment and our climate impacts the products on our shelves. And who knows, you might be one of the ones that likes it. If you have any questions, please don't hesitate to reach out, and thank you so much for watching.
So as Niall said in my introduction, I did receive my bachelor's from The Ohio State University and my master's from Oregon State University, and I am currently a PhD candidate, and as long as everything goes well, we'll be finishing this April. So my passion is really in sensory science, but prior to going to Oregon, I knew nothing about wine other than that I liked to drink it. So really launching into this project has been a lot of learning of how not only winemaking works, but how intricate wine is and how the environment produces what is on our shelves. So today I'm going to go through two of the major questions of my dissertation. So the first one is, when is a wine considered ashy? So this ashy aftertaste is kind of a key flavor difference in wildfire affected wines versus non-affected wines. It lasts quite a while in the mouth. It's kind of like licking an ashtray or that smell on your clothes the day after a campfire. It's not overly pleasant and is really a key differentiator that we're trying to better understand. So as I mentioned in the video, there are two flavor compounds that have been identified to cause these smoky and ashy flavors. The first are volatile phenols. Now, these are pretty well understood. They are contained within wood fire smoke. They're found in smoked meats, smoked cheeses, and are found in non-wildfire affected wines. They're naturally occurring in certain grape varieties and also are introduced to wine through oak aging, since oak barrels are generally toasted, producing these phenols, which are then imparted to the wine, which makes this quite a challenge to be able to identify what is the difference between a smoke-impacted wine and a non-impacted wine from a chemistry perspective, as the oak barrels can introduce the same amount or larger amount of volatile phenols to a wine. So this really led our lab to try to understand, okay, what else is happening in these wines that is producing this off-putting ashy aftertaste? And we burnt a lot of things, tried a lot of different solutions, and eventually identified volatile thiophenols in smoke-affected wines as well. So these, along with the volatile phenols, when they are present within a wine, really produce this ashy aftertaste. Whereas with phenols, we have a lot of research out there and a lot of understanding of the flavors that they introduce into foods and beverages. Thiophenols have a lot less understanding. So when we're trying to determine at what point is a wine recognizably ashy, we really wanted to focus on the concentration of thiophenols, as there's not as much information out there. So how we did this was we used an adaptive staircase procedure and asked consumers, is this wine ashy? So we would have a wine that had a consistent level of volatile phenols at 3 different levels over 3 different projects. So we used a low, a moderate, and a high level of phenols, and we would alter the amount of thiophenols within each sample. So when we would present a wine to a participant, we always started at the middle point. We would ask them, is this wine considered ashy? If they said yes, we would decrease the concentration of the thiophenols within the wine. If they said no, we would increase the concentration of thiophenols, and at some point they would start bopping back and forth between yes and no, which is how we would know that we found that recognition threshold level. So our results showed that we saw that there was differences in the threshold level of thiophenols at the 3 different phenol levels. And with that, it was an inverse relationship. So at a low level of the phenols within the wine, it required a higher amount of those thiophenols to be recognizably ashy. And then at a high level of phenols, it required less thiophenols to be recognizably ashy. And now this is really important, especially for the wine industry, as these phenols are added to wine at different parts of the winemaking process. Understanding that how different winemaking decisions, like aging in oak barrels, is going to impact the perception of your resulting wine. You may test your wine before you put it into oak barrels. Everything's good. It's not going to, none of the levels indicate that it's going to be ashy. But as you add those phenols from the oak barrel aging, you may push your wine into that more ashy perception. So the second major question of my dissertation is, what do consumers feel and think about these wines? So while this issue has been around for nearly 20 years, there's been limited research into how consumers feel about these wines. It's overall been considered a wine defect, but we do know that consumers like smoke flavors, as smoked meats and cheeses exist. Whiskeys, Scotch can be overly smoky. So are there consumers that actually aren't bothered by these smoke flavors in their wine? So to do this, we conducted this research in New Zealand. So New Zealand, while they have a wine industry, they do not currently experience the impacts of wildfires on their wine production that other regions like Australia and the west coast of the United States currently have. So this led us to have consumers that didn't go in with a bias towards smoke impacted wines already. So these red wine consumers responded to their overall liking, the emotions elicited, along with the sensory attributes within each of the wine samples we presented. And the wine samples were split between two different parts. The first, we're looking at blends of a smoke-impacted wine, so taking a smoke-impacted wine and blending it with a non-impacted wine, and then also presenting the smoke-impacted wine with different labels. We noticed in Oregon following the 2020 wildfires that a lot of wineries made various decisions in how they communicated this problem to consumers. The first choice was that a winery may choose not to produce wine at all, not to damage their reputation or produce a wine that they didn't have a flavor profile that they were proud of. Other wineries they produced wine, but they didn't really communicate anything to consumers. They just put the year on it. And if you knew about the fires in 2020, you may kind of know that it was an impacted wine. Otherwise, you just wouldn't have any additional information. Then some wineries were very transparent, saying that this is a smoky wine, that it is a unique flavor, experience the differences that you can see with different vintages. And then finally, a few years ago, a lot of wineries banded together and produced a wine for charity. So all of those grape growers that lost their contracts, the profits from the wine went back into the grape growers and the wine industry. So kind of seeing how these different options change consumers' perception of the wine. So from that first part, looking at the blends of the smoke impacted wine, we found that there were two clusters of consumers. So we have the smoke likers that liked the smoke impacted wine significantly more than the non-impacted wine. And then we also had the smoke dislikers, those that liked the smoke impacted wine significantly less than the non-impacted wine. Now, we did expect to see both likers and dislikers within the population. However, what was surprising was that they were about equal, and actually more individuals fell into the smoke liker category than the smoke disliker category, indicating that in this population, one that is not currently as familiar with smoke, they actually didn't mind the smoke impacted wine. Further with that is that smoky flavor was not found to be a driver of liking nor disliking in the wines. So smoky flavor in sensory research of these wines has been a focus of being a key indicator of smoke impacted wine. While these smoky flavors are introduced to a wine and are a great way to tell is it smoke affected or not, it doesn't necessarily relate to what consumers' opinions may be. So if you're using the sensory research to try to understand how well a consumer may like it, it's better to focus on other sensory attributes, such as the ashy tobacco flavors and some of the more chemical notes, which were more found to be detractors to liking. For the labels, we've found, kind of as to be expected, what you describe on the label impacts how people perceive the wine. So when we describe that kind of sad scenario of grape growers losing contracts and that this wine was for charity, it did make people feel sad. If we describe a wine as smoky and that these are unique flavors from a wildfire vintage, people found the wine to be more smoky. However, while we did notice these changes, it didn't overall change people's liking of the wines. They liked the wines no matter what label was presented. A key difference we did notice, though, that from the blend portion of the research, those wines were presented blind, just very standard in a glass with a 3-digit code. So those dislikers very much disliked that wine, but when we started to present it with the label, they liked the wines significantly more, which indicates that when we're considering how people generally consume wine, you usually know what variety you're drinking, if not seeing the entire bottle and the label together, that this is going to impact how much you like or dislike a wine. So the key findings from my work are, first off, that smoke impact on wine is a very complex issue with a lot of different inputs. So this starts on the vine. It depends on how long the smoke exposure is, the intensity of the smoke exposure, at what point in the grape growth cycle the smoke is applied, what variety of grape it is, and then carries on through the winemaking process as winemakers can make many decisions. What type of yeast are you using? Are you fining your wine? Are you blending your wine? All of these change what the sensory profile of the wine is going to be at the end. So really understanding and making sensory informed decisions throughout the winemaking process will make sure that you have a wine that is going to be accepted by consumers. Next is that there's a high variability in consumer perception of smoke-related flavors. This is very standard, as no two people are the same, but it's really important to know that when you are tasting a wine, especially if you're a winemaker, tasting a wine by yourself or only with a couple of people, really understanding that there is this wide variation that occurs in the population, and how do you best make decisions when you don't know what your specific sensitivity is compared to other people around you. Additionally, there's around 1/6 to 1/10 of the population that can't perceive these flavors in wine. So that adds another level of variability of you don't know that maybe you're completely unsensitive to it, and really understanding that, okay, my sensitivity is too high or not at all. So how do I find other people to taste the wine to be able to understand how intense these smoke-related flavors are? And then finally is that it's not regarded as negative by all consumers. There are consumers that do like the smoke impacted wines. And how can we be able to target these consumers in future wildfire years? And all of this has really led some of the research to the question of, is smoke impact an inherent wine defect, or does it introduce unique flavors to the wine? Vintage differences are already very well known. You're not going to buy a wine from 2018 and then from 2019 and then to taste identical. These environmental conditions, rain, sun, wind, all impact a wine. So is smoke just another environmental condition that is going to lead to different flavors in the vintage? So thank you very much for listening, and I'm happy to take any questions.
Jenna, thank you so much for that very interesting presentation. Again, some kind of the sensory side of wines and foods, something I wouldn't be familiar with, so thank you so much for that. If you're happy, we will move over to Ivannova, and then we can cover all the questions at the end.
That's good.
Yeah, perfect. Thank you so much. So again, if anyone has any questions, please feel free to put them in the Q&A box, and we will cover these at the end. But now I'll pass you over to Ivannova Lituma and her presentation. Thank you.
I would like to start with the context of my research.
Hi, Ivannova. Apologies. I think your connection is frozen. Do you want to turn your camera off and see if that helps?
Yeah, yeah.
Perfect.
Okay. Let me know if there is any other problem.
Your slides are just loading up now. Yep, we can see that now. Apologies, Ivannova, there's no sound on your video.
Oh.
If you want, you can email your slides to me, Ivannova, and I can share them.
Let me try now, and you can let me know if they
Yep, thank you.
sound right now.
Culture or CEA.
Yep, thank you.
Okay, perfect. So I'll start again. Sorry.
2050, it is estimated that the world population would be approximately 9.7 billion people. New technologies will be required to feed everyone on the planet. Agriculture is a major contributor to pollution, deforestation, and the loss of natural resources like water and fertile soil in many parts of the world. Also, climate change adds to the pressure of food scarcity. One way to increase food production in the future is by using controlled agriculture or CEA. This technology facilitates the sustainable production of plants in grow chambers, vertical farms, and greenhouses. Hydroponics is a CEA in which the plants are grown without soil using a water-based fertilizer solution. Hydroponics offer a good option for a sustainable and safe production. However, little is known about food safety in hydroponics. Decontamination techniques are necessary to prevent the risk of foodborne diseases due to the presence of human pathogens in the produce. Hello, my name is Ivannova Lituma, and I am a PhD student at Louisiana State University working in Dr. Adhikari's Food Safety Lab. My research explores the effect of UVC light treatment against Listeria monocytogenes in hydroponic systems. UVC light is one of the three categories of UV light. This technology has shown germicidal potential by damaging the RNA and DNA of bacteria. It has been used as an option for food decontamination and has FDA approval for use on food. Since outbreaks related with leafy greens has increased over the years, and lettuce is one of the most common crops produced in CA as hydroponics, the goal of this research were to evaluate the application of UVC light against Listeria monocytogenes present on hydroponic lettuce and during the growing stage of lettuce in hydroponic systems. Also, we evaluated the impact of the UVC light on the quality of lettuce. The results showed that the exposure of seeds to UVC light for 20 minutes reduced the Listeria monocytogenes population without adversely affecting its germination potential. UVC light treatment for only 50 seconds can reduce Listeria monocytogenes on lettuce leaves without affecting its weight, color, and overall quality after the treatment and during storage. Also, our data suggested that routine short exposure of UVC light for less than 1 minute may reduce food safety risk and maintain the quality of the produce in hydroponic systems. Thanks for watching this video. If you have questions, please don't hesitate to contact me. By 2000.
Okay, so that was the video.
Sorry, Ivannova, just one wee second. Your
About
video.
me, I am.
Your video was frozen there, Ivannova, but I've put it into the chat for attendees can watch after as well if they need to, if it was frozen on their end. But again, feel free to carry on with your presentation now. Thank you.
Okay, I'm sorry for that. Thank you for the introduction. I went to Zamorano University in Honduras, and I did my master's at LSU and my PhD, and right now at LSU too. I'm second year of PhD, and that was my master's research. So this is the title: Effective UVC management against Listeria monocytogenes on hydroponically grown lettuce and its effect on quality. So there are many benefits about hydroponics, and is the resource efficiency, the use of land use, the control environment, reducing waste, and improving the plant growth efficiency, reduce the use of pesticides and weed problems, year-round production with the seasonal limitations, and lower carbon print, because we can reduce transportation emissions, and also we can match this sustainable way of production with renewable energy resources. And that's why we were looking for a decontamination technique that match this sustainability. So that is why I decided to use a UVC light to decontaminate the systems, because UVC light has germicidal potential and it has been being applied to food without damaging the quality of the food and decontaminated the surface of the food. So that we wanted to have a broad approach of the decontamination of the hydroponic system to keep it to make it more safer for consumption. So we start with the seeds. With the UVC light application to lettuce seeds, we evaluate the microbial reduction, but also the germination evaluation because we don't want to damage the germination potential of the seeds. We discovered that 20 minutes of exposure reduced good numbers of bacteria, Listeria monocytogenes, and also did not affect the germination potential. Actually, we had higher numbers of germination with the 20 and 40 minutes of exposure to UVC light. Then we started to apply UVC light to the lettuce. We purchased hydroponically grown lettuce, and we used the leaves to test different times and different distances of the UVC light. So we did a microbial evaluation to see the reduction of Listeria, a quality evaluation evaluating the color change, the weight during after the UVC light application and during storage, and the surface evaluation. This is important, and I will explain more about it later. And then after that, we decide what was the best treatment to reduce Listeria population, but also keeping the quality of the produce. So that, and then we did the hydroponic system UVC light application. We applied UVC light every day while the lettuce were growing in a hydroponic system. We did the microbial evaluation to check the Listeria reduction and a quality evaluation. I mentioned the surface, and the surface is important because it plays an important role in UVC light treatment. In picture A, you can observe a smooth surface, a more flat surface, and picture B is what we call rough surface. That is more wrinkly. So we inoculate these two lettuce leaves with Listeria monocytogenes, and then we evaluate the what was the Listeria after different light. And you can observe in the smooth surface of the leaves, we had higher reduction compared to the rough surface. And this is because the leaves, when they're more wrinkly and the texture has valleys and mountains, it's like pockets for bacteria to hide. So this is important because we need to highlight that UVC light do not penetrate the product. Just decontaminate while it's in direct contact with the UVC light. So that is one of the things that we were very conscious about to make the treatment. And then the other thing is that we evaluated quality. So we had treatments from 10 to 50 seconds. We had a good reduction, and then we were wondering what happened if we increased the treatment. So we went from 1 to 5 minutes. What we found is after 1 to 5 minutes exposure, incremental on the leaves, black and brown spots along the leaves that were maybe associated with oxidative activities on the leaf that was maximized by the UVC light, or maybe associated with burns produced by the UVC light. So that's why we decided 50 seconds of exposure to UVC light were the best treatment. So we can reduce, but we do not damage the quality of the leaves. So we have 50 seconds of UVC light to a hydroponics of the lettuce were growing from day 16 to day 25 of the cycle of the lettuce. Day 0 is the inoculation day. So the first application was on day 1. And after just 2 days, we have 2 log CPU program, what is very good for us because we don't have that higher number of bacteria in a normal environment. And then after the whole treatment, there was 50 seconds every day for 10 days. We had 3.85 plus minus 1.09 log CPU per gram. And we didn't see any change in the quality of the lettuce, and also did give us the opportunity to apply the UVC light with more area of contact with the UVC light because the lettuce is growing, so it's smaller, and also the leaves are not that wrinkly and a little bit separated. And that is the results from this research. You didn't watch in the video, but Listeria monocytogenes were reduced on lettuce seeds after 20 minutes of exposure without adversely affecting the germination properties of the seeds. The UVC light could be a potential intervention strategy for reducing the risk of Listeria monocytogenes lettuce during hydroponic production. The surface set of the leaves plays an important role in UVC light effect over pathogens, and our data suggested that the short UVC light exposure for less than 1 minute may reduce the food safety risk and maintain the quality of the produce. So that was my master thesis, but right now I'm doing my PhD. So I'm still working in hydroponics because we believe that we need to develop more information about hydroponics. And this is a good foundation to, in the future, have more regulations that are fitted for these type systems. So I'm working in biofilm formation because I work with Listeria, and one of the problems with Listeria is the biofilm formation that is difficult to get rid of with normal cleaning and sanitation. I'm working with pick and shell extract and the rockels that are the substrate that we use for hydroponic systems. For the biofilm formation, I evaluated different types of surfaces that we use in hydroponic systems like HDPE, PVC, and vinyl. And I evaluated what is the growth of Listeria and the biofilm formation, comparing in the distilled water and also the fertilizer solution. And as it was expected, the fertilizer solution had a lot of nutrients, so we Listeria level more 42 log/CFU per centimeter square, and it were more high grade compared to the control that was distilled water. So we were wondering, hey, what can we do about it? So we started using UVC light to decontaminate these coupons that were inoculated with Listeria. We applied UVC light with a 1 centimeter distance, and also we did it for 7 days. And then we have reduction, you can see. We reduced 1.76 to 3.28 log/CFU per centimeter square in all coupons, the different surfaces, keeping fertilizer solution for 7 days. I mentioned that I'm working with pecan shell extract. So pecans are, Louisiana is a large producer of pecans, and 50% of the weight of the pecans is the shell. And we don't have a use for the shell, and we discovered that it has phenol bonds with antioxidants and antimicrobial properties that are effective against Salmonella, E. coli, and Listeria monocytogenes. So we start working on this with this pecan extract to do acid treatment. We apply UVC light, yes, but it is more like a short decontamination before going to the hydroponic system. This is more an approach to treat the seeds before, and then it can be stored. So we are working with 2 different treatments, coating and priming. I'm doing coating, mixing the pecan shell extract with sodium alginate, and the priming is only pecan shell extract. What's the difference between these two? The coating is the pecan shell extract with the sodium alginate goes is coating the seeds in outside, and the priming is where you put the seeds for several hours in the pecan shell extract, and the seeds will absorb the solution. What we found is that we had reductions in both treatments, but that the higher reductions were found in priming. We had a significant reduction of 3 plus minus 0.52 log/CFU per gram after 6 hours in 10% of pecan shell extract. And the higher reduction with coating was 1.06 plus minus 0.21 log/CFU per gram with 5% of pecan extract mixed with 2% of alginate. Also, we did a germination evaluation because, as I mentioned, we need to check if the treatment is not affected the germination potential of the seeds. So actually, we found that after the priming treatment, we have higher reductions. And since we developed these for farmers, we right now are working also in testing these treatments against plant pathogens. I do not, that is not in my background, but I'm learning about plant pathogens now, and we're working with Pseudomonas syringae to test if the treatment works against plant pathogens too. And the last experiment that I'm doing right now is the disinfection treatments for rockels that are the substrates that we use for hydroponic systems that give support to the plants, as you can see in the picture on your right. So these rockels are not biodegradable, and there is in the US is what the producer use in hydroponic systems. So we are validating boiling water and treat was developed at LSU to check if we can reduce decontaminate these rocks so it can be reused in the hydroponic systems. So what I'm going to be more than happy questions.
Cool. Apologies for the technical issues that we had with Ivanova's presentation. But thank you so much, both Jenna and Ivannova, for your great presentations. It was all really interesting. We'll now move on to the Q&A chat, section. And if anyone has any questions for our speakers, please continue to use this box. We have had a few questions come in, so I will get to those. Just 1 second. Okay. So the first question is for Jenna. So is there any potential health risks or impacts with biophenols or the smoky, ashy taste?
We haven't currently found any health impacts. It's not the same as like breathing in the wood fire smoke. Again, these are very similar to what's already found in smoked food products. So I think there still is a little bit more research on the biophenol area, but not currently identified that there's any health risks. And they're also in extremely low concentrations. We're talking around nanograms per liter.
Okay, cool, thank you. And again for Jenna, did you find smoke impacted labeled wines made some consumers apprehensive to taste?
No, not in the population in New Zealand. Actually, just more anecdotally, I went wine tasting in New Zealand quite a few times and talking to winemakers there and also just fellow consumers. They were excited by the idea of having smoky flavors in wine. So I think it's just kind of that different approach of some areas have really attacked it at this is a problem, and they're like, oh, that might be a unique opportunity.
That's really interesting. Thank you. And the last question so far for Jenna is, how large was your consumer panel and did it capture different demographics? So young, old, low, high, economic groups?
We had 197 participants. It did span quite a large age range, pretty even split actually of male versus female. We didn't collect information on socioeconomic status since that wasn't one of our focuses, but we were looking at their smoke flavor liking and also their subjective wine knowledge. So it was kind of looking at how those impacted their overall wine liking.
Thank you very much. So we'll move on to some questions for Ivannova now. So the first question is, can this wavelength of UV lead to mutagenesis in the seed or plants?
I'm sorry, can you repeat the question, please?
Yeah. I think your video is frozen. We'll just give you a second to see if it starts again.
Okay.
There we go. Yeah.
Can you repeat the question?
So the question was, can this wavelength of UV lead to mutagenesis in the seed or plants?
I'm trying to hear, but it's difficult to
No, that's okay.
understand the question because it's like the connection really bad.
You should be able to view the Q&A section on the right, but I can ask you again. Otherwise, we might need to, if we're still having connection problems, we might need to ask these questions and get responses after the webinar, if that's the best way. Apologies for the technical issues. I think that might be the best approach, if that's all right. But again, thank you for the questions, everyone, and we will ask Ivannova and get some responses to these. So for Jenna, what's next for your research?
For me, as I'm finishing up, I am very much in the writing stages of my dissertation, but I am actually on Monday starting the final project of my PhD looking at coastal differences within the United States of how does the perception of wildfire affected wines change from the West Coast versus the East Coast. As I am originally from New York, I, before even starting this project, had no idea what the impact of wildfires was on communities, let alone on wine itself. I had never seen a fire before and then flew into Portland to bright red, kind of apocalyptic skies during the 2020 wildfires. So, really understanding how just even knowing what a wildfire is and having experienced its effects changes how these wines are perceived.
Really interesting. Thank you. Niles just said, so for any questions for Ivannova, please do email us at foodforthought@food.gov.uk and we'll put you in touch. Oh, hello.
I can read the questions.
Oh, okay, cool. Should we go
in the
through them
QA
then, if
section.
that's
If
okay?
you,
Cool. All right, let's go with
sorry,
that.
it's only my connection is really bad.
Are you okay
Okay,
to answer them?
So there is the first question: can this wobbling of UV lead to monocytogenesis in the seeds plant? Okay, so I checked. There is different data about UVC light, but actually there has been not information about any mutagenesis in seeds of plants. There are more research about UVB than UVC, but also is something that we want to explore. That the short exposure that I have, that is 50 seconds, is really a short exposure, so we don't think that we will have any kind of problems with that. And also, there is no information about pathogen resistance with UVC light. I mean, it's the new technology, but that is a benefit also. The next question is, how did you chart was a potential primer for this function, and is there any working going on to investigate its allergenicity? Okay, so we had in my lab, they work with pick and shell extract, and then they developed the extract protocol that we have. That was the first step. Then they evaluate what is the potential activity against different types. And for seed, we have different types of treatments. So the most common treatments are priming and coating. That is, we decide to use those type of treatments. And the priming can be with different type of solutions, like water. If you put seeds and water priming already, so you can use chemicals, enzymes, or extracts like this natural extract. And about the allergenicity, no, we haven't worked on that, but that is a really good point. We need to check. Thank you. And the last question, as well as plant pathogens, are you also looking at other GI like salmonella and stag? So for the hydroponic system, I did just work with right now because it is more when you have contamination in the environment. The serum monocytogenes will be the first pathogen that you will check for it if you are talking about fresh produce. There is also risk for other pathogens, but our first want to start first with Listeria monocytogenes and also the biofilms. So yes, maybe we will work later with Salmonella and E. coli. And what is next for your research? Well, that is my next what I show in the presentation. So as I mentioned, the UVC light in the hydroponic system was my master's research. So right now this is my PhD research that I already work with biofilms, the pick and shell extract that I'm working the formulations right now, and the rock wools. Thank you.
Oh, thank you very much for those answers. I'm really glad that we managed to get them. So thank you, everyone. Before we close, I want to flag that if you're not already on the Food for Thought mailing list, you can sign up via the link that we'll post in the chat to get updates on upcoming seminars and recordings. You can also view recordings on our YouTube channel, which we will post a link to. If you'd like to get in touch with more questions for the speakers today or previous seminars, then please don't hesitate to email us at foodforthought@food.gov.uk, or if you're at the FSA, you can search for our page on the intranet. We welcome ideas for future speakers, so always get in touch. And if you're at the FSA and would like to join our voluntary team, then please don't hesitate to reach out. thank you all for joining and have a lovely rest of the day. And we'll finish that chat now.